Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to look at a concept in volumetric analysis, and that is under the preparation of solutions. Now this concept is very important because in us knowing how to prepare solutions from substances whose concentration is unknown, this will assist us in trying to figure out what volumes are reacting and what is the amount of substance that is being used in a chemical reaction. This practice basically is very essential in trying to prepare, of course, some volumes, which we call standard volumes, of course, whose concentration is known. Now, in us trying to figure out this using the sample question on the board, we're going to see the relationship between the concept of the mole that we discussed, molar concentration, and then the relative formula mass of some of the substances that we may come across. So in this case, generally, this is going to assist us in knowing how to prepare solutions. And this is a very essential skill in trying to figure out what amount of substances is being used in a chemical reaction. So for that case, thank you and welcome. So as I've said, today's topic of discussion will be a concept in preparation of solutions. And this topic falls under the concept of volumetric analysis, of course, which is an essential part of chemistry. So in this case, this is going to assist us to know how to prepare solutions, especially when we are trying to deal with chemical analysis, maybe during research or in our lab work. So in this case, we're going to start by trying to remind ourselves some of the essential concepts that we may need to assist us in trying to figure out what preparation of our solutions basically entails. Now, we have talked about the concept of the mole in some of the videos. So we said that there is a relationship between the concept of a mole and Avogadro's number. So this is Avogadro's number, which is given as an initial n subscript a. So this is Avogadro's number, which basically states that 1 mole of a substance contains Avogadro's number of particles. It's just an approximation to that one. Basically, it's just a constant. So in this case, we're going to come across the relationship with that. And this concept of molarity basically stems from this. So we are going to look at this concept of molarity. And then we talked about a chemical reaction, the nomenclature of a chemical reaction. Now, for this, basically, I can give an example like two reactants, which are reactant A and reactant B reacting to form products C and D. So in this case, when a chemical reaction is taking place, there are different ratios of substances which are being used maybe to ensure that the reaction has gone to completion or it has attained equilibrium. So in this case, there are coefficients which are used, which precedes these symbols that are representing different chemical species or the product, which are indicated using the letters small a, b, and the C and D for the product side. So these particular letters are known as the coefficients, and they basically represent the reacting mole ratios of volumes, in this particular case for a general reaction of A, B forming C and D. So wherever we're going to talk about the reacting mole ratios of volumes, we basically implies to those coefficients or the volumes which are reacting for the reactants and products. So in this case, we're going to look at that basic concept, and we're going to see that there is going to be a relationship between these reacting ratios and what we call the relative formula mass, that is for compounds, or the atomic mass for elements. So in our case here, we are going to prepare 250 ml of a 0.125 molar silver nitrate solution using silver nitrate solid. So as I've said, of course, we're going to look at this concept. Now, molarity of a solution is a solution that contains 1 mole of a solute per liter of a solution. And of course, as we said, this one is basically abbreviated as, if it is 1, then it can be abbreviated as 1 molar. So in this case, this is a solution that that contains one mole of just 1 mole of solute per liter of a solution. Now, in this case, when we're going to look at the concept of relative formula mass, and this is the mass of the total mass of the sum of masses of different elements that make up a compound. For instance, in our case, we're going to use the compound that is silver nitrate, and this is going to assist us in finding the RFM for this, which is going to be very essential in trying to figure out what is the amount of substance that is reacting, how many moles are reacting, and the mole ratios. So for silver nitrate, these are the basically the figures which I provided. The relative formula or relative the atomic masses are provided. So for this case, I'm just going to list them somewhere for us to use whenever we come across. So this compound is made up of silver, which has got a mass of 107.9 grams per mole, and then there's nitrogen, which is made up of 14.01, and then we have oxygen, which is made up of 16.00. So in this case, these are going to assist us in trying to figure out what is the relative formula mass for the compound that we're going to use in our case. So in that case, I'm going to do away with what I've just mentioned, because I presume that we know what these ones are. These are just constants which are given on the periodic table. When we were talking about an atom, we talked about atomic mass, and then we talked about other concepts like the nucleons, etc. So in this case, I'm not going to go into that, since I assume that we have a basic information of the same. So I'm just going to look at the problem and try to solve it. So as I've said, that the molarities of a solution is basically a solution that contains 1 mole of a solute per liter of a solution, and generally we can abbreviate it as capital M. So therefore, whenever we use that one, it's going to imply molarity. So molarity of a solution is given as, so the number of moles of a solute per liter of the solution. So this equation is going to present or to give us the product of molarity, which is given by giving that ratios. In this case, we're going to see that it's simple to prepare solutions of known molarity from solids and non-volatile liquids that can be, of course, whose mass or weight can be achieved, or maybe can be measured in the laboratory using the balances or the analytical balance that we can be able to use in the laboratory. So in this case, that is trying to figure out the mass of those particular substances. And in this case, we are going to find out that we have what we call a reagent grade sample. Now, when we were talking about the concept of measurement in mathematics, we said that there is a point of reference, or what we call a standard units for various kinds of aspects or in measurement, like maybe the distance, the mass, etc. And in our case, we have what we call reagent grade substances, which actually are substances that contain high purity, and they are suitable for laboratory and analytical research. And as we have said, that in trying to find out the concentration of a known solution, we're going to use a solution whose concentration is known, which we are going to basically refer to as a standard solution. So a standard solution is a solution whose concentration is known. So basically, in trying to figure out concentration of other solutions which are unknown, we're going to use what we call a standard solution. And as I've said, this is a solution whose concentration is known. So I hope that we have maybe captured one or two concepts from what we have talked. So in case we are going to mention about the concept of molarity or a standard solution, etc., we'll be in a position to understand what basically we refer to. So we just go to our question. Prepare 250 ml of a 0.5 molar silver nitrate solution using silver nitrate solid. So in this case, we will just extract the information that we have been given from the question. We have 0.125 molar silver nitrate solution that we are supposed to prepare, and this solution is supposed to be 250 ml. Now the equivalent of 1000 ml is equivalent to a liter, so in case we use the term liter or ml, that is the equivalent for that. So now we're going to use Avogadro's concept to try and find out, or maybe the mole concept to try and find out what these two terms means. So whenever we use the term molar, we talked about the molar being referred to as the number of moles of a solid in a liter of a solution. So basically when we talk about 0.125 molar, we're saying that 0.125 moles are contained in 1000 ml of silver nitrate solution. So in this case, if we try to look at this one, we can be able to convert this one in terms, or maybe try to find out what the amount of moles that can be found in 250 ml of this particular solution, given that 0.125 molar, which implies 1.25 moles in 1000, we can basically try to find the number of moles in this volume of our solution, and then we can find it is 0.125 times 250 ml divided by 1000, and this is ml, and these are the number of moles. So therefore we can just do away with that. 1, 4. So basically we're required to find a solution that contains this specific number of moles. So let's just do an evaluation for that. So 0.125, just a minute, let me take my calculator. So this is 0.125 moles. Just doing a confirmation for that. So that is 0.125 divided by 4. So this one will give us 0.03125 moles in 250 ml of this particular solution of 0.125 molar silver nitrate solution. So in this case, we just basically after those trying to figure out those number of moles, and they use that relationship in order to find the mass that is going to be used in this case. So we are told that we're not basically told, we can just be able to find the relative formula mass for silver nitrate now that we have been given the individual atomic masses for these elements that are forming that compound. So this is going to be 169.9 grams. Sorry for that. Grams. So from the mole concept that we know that the relative formula mass of a compound is equivalent to 1 mole of that compound. So therefore, we can just say that this number of grams of silver nitrate per mole, then we can have a relationship that we are saying, basically a relationship that we are having a relationship between this. If 169.9 grams form a mole for silver nitrate solutions, we are required to find the amount in mass of 0.0315 moles. So therefore, just ignoring this volume, I can just use the two relationship. So here I say 169.9 grams and 1 mole of silver nitrate. So for the given 0.03125. We're going to do just a cross multiplication now. I hope I just do away with this so that we can use this space. So therefore, from our point there, then we can be able to say 169.9 grams times 0.03125 moles divided by, so well, we're going to just have a, we can just assume those units, although I just cancelled them in order to, for us to find the derived or just the final units for those, that product we are going to find from that calculation. So in this case, I'm going to do a calculation for that. So that is 169.9 times 0.03125. This is going to be 5.309 grams. So this is the three significant figures. So grams of silver nitrate, which are going to be contained in 250 ml of silver nitrate. So basically the question is asking us prepare 250 milliliters of 0.125 molar silver nitrate solution using this solid. So now that we have found them, the quantity of the mass that is required to be used in 250 ml of silver nitrate, there's a specific procedure that we're going to use in order to prepare this particular solution of a concentration which we have been required, which is of 0.125 molar. So the first step that we're going to take is to measure or weigh accurately. This one can be done using an analytical balance, 5.3. Of course, this the degree of accuracy for this, of course, we can just write 5.30, but we require a very accurate weighing machine. So for that case, we weigh the specific mass that we have found of the silver nitrate solid, and then transfer this is the weighed sample into a 250 ml volumetric flask. So in this case, we're going to transfer this sample that you have weighed into a volumetric flask, and then we're going to delete the content with the distilled water to the mark. Of course, when we are just trying to look at the laboratory equipment, in one of our videos we talked about the volumetric flask. Of course, my drawing is not going to represent the exact shape, but I'm just going to use an illustration for that. And basically, this one represents a volumetric flask, and this is the mark, and this basically is a 250 ml volumetric flask. Now the concept here is to transfer the weight sample, which consists of course this mass, into the volumetric flask, and use the distilled water to dilute or just to fill it to the mark, and you shake vigorously and let the solution to rest for some time for the solution to take place. So in this case, we're going to see that this is one of the ways in which we can be able to prepare a solution of this required concentration. Whenever we are going to try and do some of the analytical work, maybe in the laboratory or during our research. So in this case, of course, there's one precaution that somebody has to, someone has to take into consideration whenever trying to make solutions of this kind, in that you do not have to fill the volumetric flask first before you transfer the weight sample, because there are some other cases whereby you can find that the resulting solution may actually be larger and or maybe smaller than the 250 ml due to interaction of the solute and solvents. There are some other chemical reactions which of course may be wrapped, as I can use this term just loosely. Some chemical reactions can be able to take place, and then you find that some of the volumes have been spilled, etc. So this basically is the procedure that we can use to solve such kind of solution. So first, find the relationship between the provided information for the concentration in terms of number of moles, in that one relative formula mass for a compound consists of 1 mole. Number 2, the relationship between the number of moles and volume. So whenever a substance has been indicated as molar, that is the concentration or the number of moles per liter of a solution. So you use that information in order to try and figure out how you can be able to calculate that number of moles required in that. So basically that's how we prepare the 250 ml over 0.125 molar silver nitrate. And also bear in mind that these are the constants which are provided. So basically we do not have need to cram them or just maybe do a memory of them. So we'll stop there for today. I hope that you have understood the concept of the procedure for trying to prepare the solutions of these unknown concentrations. And this is going also to be stressed in one of our topics that we're going to discuss on standardization of solutions and one of the concepts in volumetric analysis. So that is it for today, guys. Bye. God bless you.